To get a good understanding of how stars actually work, we do need to talk about how stars get their energy. Where is that energy coming from? And fusion is where stars get their energy, but what we do want to focus on here is the difference between fusion and fission and how energy is created in both. So, as always, three essential questions: being able to differentiate between the two, fission and fusion. So, what's happening with atoms in both type of energy creations? And then specifically with fusion, what's happening for stars? And we'll see kind of three steps that we're going to focus on when we talk about fusion within a star. Now, this notes is a little bit different. We've got a couple segments from our textbook that we want to read to get a little intro about each energy before we start talking about it. So go ahead, pause the video, read the couple paragraphs there, and as you do, you're kind of looking for the most important part about fission, basically its definition and how it relates to energy. So go ahead and pause with your highlighter and find a couple important things. So to summarize what we just read, we want to talk about how fission occurs on Earth. Fission is a type of energy that we do create here on Earth, man-made. And what's happening with that is we are causing neutrons. Remember, neutrons are atoms. We're causing neutrons to collide with the nucleus of another atom. And of course, nucleus is the center. So we have some fancy technology that can fire neutrons at other atoms so their nucleuses collide. And when this happens and those particles collide together, what we notice with fission is that their nucleus then splits apart. Their nucleus splits apart, and hopefully you still have your highlighter out from your underlining and highlighting in the paragraphs there. This would be something important to highlight. Okay, this is our definition of fission and how energy is created through fission. When the atoms collide together, the nucleus is then split apart. Now, when that happens, the neutron is now unstable. Okay, unstable. And so what we know then, fission is coming from a word meaning to break apart. And again, that goes with our definition of the atoms. The nucleus is splitting apart when fission occurs. And we use it here on Earth to create nuclear energy. Nuclear energy. So, summary of fission. Fission does happen here on Earth. It is a man-made scenario where we are firing neutrons at another atom to try to create that nucleus to split apart. And the splitting of that nucleus makes the atom unstable, but we are gaining quite a bit of energy from this process. That is why nuclear energy is so very powerful and so very dangerous with all these remaining unstable atoms. So now let's investigate fusion a little bit. You've got a teeny tiny paragraph there on the bottom to read, and you are now looking for two brand new pieces of information about fusion, which occurs in stars. And as we read that little paragraph, we want to think about this question: which type of reaction is more powerful? Which one's going to be stronger? So pause, read, underline those two new things, and then go ahead and circle your answer there. Which is more powerful? Couple things that we've learned in that paragraph there is that fusion reactions can release more energy than nuclear fission. We know now that fusion is the process of two or more nuclei combining together. So when we think about this question, which is more powerful, we should over here be circling fusion. Fusion is much more powerful, more energy produced here compared to fission. So we've got to think about, where's our energy coming from? Because fission, we said, happens on Earth and is very powerful, but we are getting most of our energy from the sun, right? 99% of the Earth's energy is coming from the sun. So what's happening inside the sun to create all that energy that Earth can use? Well, the sun, being that it is so close to us, that we are here, of course, on Earth, the sun is so close to us that we can study it much better than any of the other stars. So we've studied it and kind of used the information we know about it to apply to the billions of other stars that we know of. And what we found is that all stars work very similarly using fusion. Okay, so again, we're going to pause. We're going to read a couple paragraphs here, underlining in each paragraph at least one important thing about fusion and how it relates to our stars or our sun's energy. So pause again, do a little underlining. Okay, to summarize here, fusion does occur, like we said, in stars. So this is what we're thinking about for our sun. And fusion requires two atoms, in this case, two or more. But what's happening with those two or more atoms is they are combining their nuclei. Requires two atoms, to combine their nuclei. So what's happening now in fusion is those two particles merge together into one. Okay? And the result gives us an immense amount of energy output. This result of the reaction creates a huge, much more than we could ever have with nuclear energy on Earth, a high energy output. And we know from looking at the electromagnetic spectrum that really high energy output is going to be on the gamma scale. So we can see here, after these things have combined, we are getting gamma energy coming out of these nuclear fusion reactions. Okay, so just a quick pause to compare the two. We talked about fission, where the atoms combine and then split, and we're talking about fusion here, where the atoms combine and then stay together. Okay, so just a little side note here when we're talking about the difference between fission and fusion. Like we said, fission splits into two, and so notice here there's two S's in fission, where fusion actually fuses two or more atoms together to become one, and hey, there's only one S in fusion. So just a little note to kind of help you remember the difference, where fission splits apart into two, fusion fuses together into one. Now the third thing, and probably the most important thing to think of for stars, is that a new element is formed when this happens. A new element is formed. This allows the star to kind of keep regenerating and keep going. So it's basically fueling itself with these new elements that are being created. To start out most stars, the new element that is typically fused is two hydrogens fused together to make helium, He. Now stars are really good places for fusion to happen because there are so many particles there. They have a really high density. There are so many particles crammed into this one massive place that all these particles are bumping around, bombarding each other, and the temperature is extremely high. The particles are everywhere, so it's super likely that they will start to collide, and the pressure is also high. All of these conditions work really well for these particles to collide and become one and fuse together. Now it is important to note that fusion doesn't regularly happen on Earth. Okay? there's just not enough density and not enough pressure for really to make that happen on Earth. And that's good. We don't want gamma energy scooting around all over Earth. But the density inside the sun is so much bigger. It is over 100 times that of water. So there's so much more molecules packed into a small amount of space when we're talking about what's going on inside of stars. So all this energy is being created, which we would think would make the star kind of grow and expand and almost explode with all this really strong energy. But there is a second force that helps balance out the force of fusion. And that force we see here is gravity. So fusion and gravity actually work together to keep the star balanced and contained into that circular shape. Okay, what we know is happening is that fusion occurs, we get new elements forming, and that causes the pressure inside the star to increase. Right? All that energy being created causes the star to build outward. So we can see down here, our little key, we want to draw in a red arrow showing, pressure starts to build outward. But because there's so many particles inside that star, gravity is also present. And because there's so many particles, gravity's force is pretty high. And so gravity is able to kind of tame down and balance out the pressure. We can see here we have our green arrow for gravity. We want to show that that force then balances out the pressure. And so those two things counteract each other, and these two forces actually balance each other out, keeping the star functioning and performing more fusion, but keeping it balanced at the same time. So make sure on your little diagram there, you draw in and you label that the pressure here is going outward, while the gravity is kind of keeping it in check. Now we'll see as we start to look at the star's life cycle is that one of those can take over and cause some different things to happen within the star. But in terms of fusion, we see it happening in several of the star stages, and we're just going to highlight two right now. Two stages that every single star goes through. So every single star will be creating this type of fusion. In the main sequence stage, which is the stage our sun is in right now, it has an abundance of hydrogen, which is H, okay? And so it has all this hydrogen from its initial kickstart from the nebula, and it's got a whole bunch of hydrogen atoms that will fuse together, and as they fuse, they become one, right? Fusion happens to create the element He, or helium. So it continues to use up all that hydrogen while it is creating more fuel in the form of helium. As that happens, of course, it is making energy for itself. More energy is created, and we know that can be in the form of gamma. Very strong energy coming from that fusion. And again, we can see it here in the diagram. We can see the gamma energy being let off from the combining of nuclei. Now, as that hydrogen starts to run out, the star will then kickstart using helium for its fuel, and that happens in red giant stage, which is where the sun would go next from its current stage of main sequence. Now don't worry, we won't be in red giant stage for a while, but helium in this case is now the main energy source, and it will combine together. So He, helium, will fuse together and create a bigger, heavier element, which in this stage is carbon, or C. And again, as it's making a new element, an even bigger and heavier one, even more energy is being produced now. So again, the difference between fusion and fission is our important fact here, and how specifically fusion is helping our stars grow and function. So back to our essential questions. You have a little space to answer them on top this time. We want to make sure what's happening with atoms in both fission and fusion. And as you write that sentence out, remember our little S trick there. And then for the third one, how is fusion producing energy for stars? And you can think back to those 3 steps that we talked about and kind of summarize these. Maybe even give an example of the elements that are fusing and occurring in those different stages.